Continuing on here, we need to solve and check. So remember, checks are really important. This one looks a little different though, because you can see that we have square roots on both sides. But it's actually these ones are one of the easiest ones, because if you see a square root covering all of the left and a square root covering all of the right, you can just square both sides. Whoops. And then you can cancel those out. And you have x plus 8 equals 2x minus 4. From here, we need to get the x's onto the same side, so I'm going to move this x over to that side by subtracting it. And then I'm also going to move this negative 4 onto this side by adding it. So that will get rid of that. And then I move the x over, so that'll get rid of that. So I've got 8 plus 4, which is 12. Is equal to 2x minus an x. Well, 2x minus an x is just an x. So x is equal to 12. So that looks like our answer, but we do need to verify that it actually works. So we're going to do a check here. And so we put it into our original equation. X plus 8, well now we've got 12 plus 8 is equal to 2x minus 4, or 212 minus 4. On the left side, 12 plus 8 is 20, so the square root of 20. On the right side, we have 2 times 12 is 24 minus 4. 24 minus 4 is 20. Now, I don't know what that is, but I do note that the square root of 20 is indeed equal to the square root of 20. Those are equal, so I can check those off. Our answer is correct. So now we can move on to B. Again, you get a square root covering both sides, so I will go there and there, square both to cancel the square roots, and that will cancel with that. So I have a 2x plus 8 is equal to x minus 4. And again, I'm going to bring this x over to here to get all the x's on one side, and then bring that 8 over to that side. So to move over the x, I'll just subtract it from both sides. That'll get rid of that. And then I'm going to move over the 8, it's plus 8, so I'm going to minus it onto this side. So I have 2x minus x. Again, that's exactly the last one. 2x minus x is just an x. And negative 4 and negative 8 gives me a negative 12. So I should get x equals negative 12, assuming that's right. And then I need to, of course, check. Is this correct? So if I check it, I can put this into the left side. 2x, x is negative 12, plus 8. And then the other side is going to be x, which is negative 12 minus 4. So let's see, 2 times negative 12 is negative 24. Negative 24 plus 8 is going to be negative 16. And on the right side, I have negative 12 and negative 4, which is also negative 16. Now, if I look at this, I see, well, yeah, these are the same. They do match. However, I'm not allowed to square root. I can't take the square root of a negative number. It's actually not in the domain. But we've known that for quite a long time. You can never square root a negative number. So even though I do get these things the same, it doesn't work. I have to reject this answer, because if I put the answer in, I get an impossible answer. I get the square root of a negative number. Let's look at letter C. Again, I get a square root over the entire left side and a square root over the entire right side. So that actually works out quite nicely, because I can just square it. We'll come to ones where there isn't a square root over the entire thing. But this one does. So those will cancel and those will cancel. And I'm left with x squared minus 10 is equal to x plus 2. Now this is the very first one we've seen where we now have an x squared in the equation. And if ever you have an x squared in an equation and an x, the chances are that you're going to need to bring everything over to one side. So I'm going to bring everything to the left, because I like to keep this x squared positive. If I bring that x squared over here, it becomes a negative x squared, and I don't particularly want that. You could do it, but I just don't. So I'm going to bring these two over by subtracting. So I'll subtract the x, negative x, and I'll subtract the 2. And I'll subtract the x, and I'll subtract the 2 onto that side as well. So those will be gone. Now x squared minus x, I can't actually do that. They're not like terms, so I have to just write them side by side. However, the negative 10 and the negative 2 does make a negative 12. So I get x squared minus x minus 12. And from our previous units, we've seen that this is something that's factorable. So the left two have to multiply to x squared, so x times x gets you x squared. And the right side needs to multiply to negative 12. So maybe I would try negative 6 and 2, because those do get you negative 12. In order to check, you need to take a look here at the diagonals. I've got a negative 6x if I multiply these two diagonals. And these two diagonals is a positive 2x. And if I add those together, 2x and negative 6x gets me negative 4x. And is that my middle term? And the answer is no, it's a negative 1x. Okay, so I need to just choose, and we did a lot of this, we need to try different numbers. So we'll try negative 4 and a 3. So I'll multiply one diagonal, I'll multiply these two, and I'm going to get a 3x. Multiply these two, and I'll get a negative 4x. And put those together, 3 minus 4 is negative 1x, and that is indeed my middle term. So there's other ways to factor, but that's just the way that we did it in class. So we have x minus 4 and x plus 3 is equal to 0. So now, when we have something like this, we can say, well, we've got two equations. We have x minus 4 is equal to 0, or we have x plus 3 is equal to 0. And then for each of them, so we could add 4, we can solve these, and this one we can minus the 3. So we have x equals on the left here, 0 plus 4 is 4, and 0 minus 3 is minus 3. So I have two answers, x equals 4 and x equals negative 3. This is the first time where we've got two answers. And so when we do our check here, we're actually going to have to check both. We're going to have to check when x is 4, and then we'll have to check when x is negative 3. So we'll have to do both of those checks. All right, well, let's do the first one here, x equals 4. So on the right side, we'll have x squared, or 4 squared, minus 10 is equal to 4 square root of x plus 2, or 4 plus 2. Notice I didn't put a 4 into one of them and a negative 3 into the other. We're putting a 4 into both, and then we'll put a negative 3 into both. So 4 squared is 16 minus the 10, and this side is 4 plus 2, which is 6, and 16 minus 10 is indeed 6. So that one works. Next we can try negative 3. So we'll have the square root of x squared minus 10, or negative 3 squared minus 10, is equal to the square root of x plus 2, or negative 3 plus 2. So I have here, negative 3 squared is 9 minus 10, and on this side I've got negative 3 plus 2, which is negative 1. And here, 9 minus 10 is negative 1, and this is negative 1. So it looks like, hey, it works, they match. But then we have to remember, well, we can't square root a negative number. So even though they match, and they do make a true statement, the statement actually isn't true because you can't square root the negative number. So it looks like our x equals 4 one is working, but the x equals negative 3 has to be rejected. So I need to indicate to the reader that, hey, we're going to reject the x equals negative 3, and we're only going to keep the x equals 4.